correction. As Carla said, I'm an oceanographer, and my research primarily to use a set of models to study the physical, biological processes in the ocean and how that regulate global carbon cycle. And then particularly, I have done quite a bit of work on iron fertilization experiments, but primarily with the physical biogeochemical models to study the impact of iron fertilization on the ecosystem productivity and the carbon sequestration. So tonight I'm going to talk to you about the three topics: carbon cycle, global warming, and then the climate intervention technology. I think this is kind of a new idea and concept, and then we are still dealing with this. This is an evolving and a very important topic, but I'm going to spend more time to talk about iron fertilization and then what is the latest discussion on this topic. First, let's start with a global carbon dioxide budget. This has been done very recently. As you can tell, for the past decades, the fossil fuel emission increased by about 15% compared to just decades ago, 1990. And then, so right now, the fossil fuel emission roughly about 7.7, that's gigaton carbon per year. And yet accumulation of carbon in the atmosphere increased by more than 20% during the past 10 years. That's because the land and the ocean ability to absorb this anthropogenic carbon remained a constant. There are some studies indicate that the ability of ocean absorbing this anthropogenic CO2 start to decline, and therefore we'll expect a more carbon dioxide will remain in the atmosphere. That therefore will lead this increase of a carbon dioxide concentration. One of the consequences of this increase of the carbon dioxide as greenhouse gases is the warming. And then this is the latest global temperature index and showed that for the past 30 years, and then the global average temperature increased at about 0.2 degree centigrade per decade. So this right now we're about 0.6 degree centigrade warmer than just 30 years ago. So this trend will continue because the scientists examined all the factors that may lead into this warming trend, including the solar activities, the El Nino frequencies and intensities, and they couldn't come up. This warming trend is caused by the natural climate variabilities, and therefore they conclude this is due to a greenhouse gases effect, and otherwise, or just human activities cause this warming. So the overwhelming scientific evidence and the fact that lead into this warming, the impact on the environment and the society, including global sea level rise, and you have heard about it, but also that has the potential to cause this climatic related disasters or extreme events, such as the heat waves, cyclones, etc. And then, as you can tell, this is past 30 years, those extreme weather-related events start increase, and there's no sign that trend will decrease. And then, so again, we don't have a controlled experiment to tell whether this is a part of the natural process or this is a part of a human activity caused. But there's a strong evidence the warming may lead into this event. Those events more frequent, more intense. So the issue is what we are going to do about it. So the data, the facts are clear. emission of greenhouse gases and the warming trend will continue, and then doing nothing certainly is not an option, it's not a solution at all. The risk of inaction will be very high, and we cannot afford to gamble our environment for the future generations. So you have heard about various policies, negotiations on the climate change to counter the climate change, including Kyoto protocols more than 20 years ago, for the last year, the Copenhagen's UN's summit, etc. But they all lead into the mitigation adaptation. So there's various methods and the suggestions how to reduce the greenhouse gases emission, but because the failure of negotiation and the policy at all levels, we just don't have a concrete plan to counter this global warming trend. So therefore, frustrated with this lack of action, and then some very concerned, a reputable scientist started to think about plan B, and then that is the climate intervention technology, and ask the question, what if the warming trend will continue and will cause a rapid climate disasters, and what if this disastrous trend will continue impact on the society, and some people put it as our human civilization, etc. So for the past few years, several reputable scientific organizations, including the Royal Society of London, American Geophysical Union, American Meteorological Society, National Academy of Sciences, all issued a statement and reports calling for research on the climate intervention technology. So that is worth looking into it. At least we need to do some research and on this very urgent and yet very sensitive topic. What is the climate intervention technology? Sometimes the people call it climate engineering or geoengineering. You might have heard in the news. It's basically the deliberate, large-scale manipulating physical, chemical, biological aspects of Earth's system to counteract the effects of global warming. There are two broad categories of this approach. One is called the solar radiation management, and SRM. And under this solar radiation management themes, there are several ideas or the schemes on how to reduce the solar radiation reach to the surface of Earth to cool the planet, basically. There are two promising or front-running ideas. One is a sulfate particles injection into the stratosphere, whether through the balloon or delivered by the aircraft, etc. The second one is a cloud seeding techniques, and then that inject a water vapor into the lower atmosphere to create this cloud, brighter white clouds that reflect the solar radiation. Therefore, it has a cooling effect. Those mimic the volcano eruptions as well as those fogs you experience in, say, California, San Francisco, or Monterey Bay. And those are two broad ideas. And the second category of this climate intervention technology is really the one called the carbon dioxide removal, and CDR. Under this approach, there's several themes. Again, one of them is a iron fertilization idea, probably you have heard, and I'm going to talk quite a bit on that. And then another one is a direct air capture of CO2. You filter the air and liquefy the CO2, store it in the geological reservoirs or pump it into the deep sea. So those ideas have been proposed, and some of the scientists have proposed a small-scale experiment to conduct those experiments. But the bottom line is all lead into the cooling of the Earth, and then so there is a evaluation or schemes of this based on three categories. That is the cooling effectiveness or the factor, and then readiness, how we can deploy this kind of experiment, and then the cost, how much does it cost? For example, a space-based mirror reflect the solar radiation. It will cost a lot of money, won't be ready in centuries, and etc. But you can see this, a sulfate dioxide injection into the stratosphere. It's ready now, within a few years. It's cheap, and it produces the maximum cooling, because we know when a large volcano erupts, it will cool Earth significantly. So, but iron fertilization, you remove the carbon dioxide from atmosphere, that takes longer. The effectiveness on cooling probably is a minimum and slow. It takes a long time to see the effect, and it has a cost associated with. So, therefore, once the scientists propose those ideas and propose the experiment, that kind of scared the public and some environmental groups, and started to think, this is not a science fiction anymore. The scientists proposed to doing this, but who will be responsible doing this type of research? And therefore, the community as large, we feel we are obligated to have a conference and open dialogue to talk about those issues, not only about the scientific ideas, but it's also associated with the environmental issues and social, political, economic factors linked with those type of research and potentially the experiment. So this meeting, I participated in early this year in Salomon. We call it International Conference on the Climate Intervention Technology. About 175 people participated. There are 4 broad groups of people: the climate scientists, the modelers, experimentalists, and there are also social, legal experts, diplomats, and then there are environmental groups, NGOs, and also the media. And then, so last week, the Canadian broadcaster CBC had a documentary which they had a film crew to film the entire conference. The title of their documentary called "Playing God with Planet Earth." If you have a chance, you can take a look of watch that documentary, the hour-long documentary. And in this the conference just released a report, and then the highlight of this conference is really this 5 principles, and then responsible conduct for climate engineering research. So you can see we saw quite a bit about this that include in the openness, the transparency on this, the international participation, evaluation, etc. And then also informing the decision-making process. So there's a link to the web conference and etc. You can download all the presentations, including the conference report, etc. So I've been working on the ocean iron fertilization for the past 15 years, and then there's a lot of similarities on what a climate engineering community is going through. The oceanography community has dealt with this very similar issue for the past 20 years through this so-called iron fertilization experiment. And then I think most of you have heard about the iron fertilization experiment. So it's all started with the iron hypothesis. So it's really just how the scientists conduct their to advance science and how they come up a hypothesis, how they test the hypothesis, and without thinking about using it, deploying it for counteract the global warming per se. So it started about 20 years ago. John Martin came up with this hypothesis that he studied iron and phytoplankton productivity and noticed that there's a lot of unused nitrate and phosphate in the Southern Ocean, equator, and North Pacific. And then he proposed that's because of lack of iron that phytoplankton cannot use up all those nutrients. So that was the hypothesis. He was also very famous for a quoting as that, give me half a tank of iron, I gave you an ice age. It was reported and talked about it in the media some 20 years ago. So that was the idea that if you stimulate the phytoplankton growth, and therefore they can take carbon with it, they will sink to the depths of the ocean. How you test this hypothesis? And then John Martin used the traditional way. You have the control that you don't add anything. You have another bottle, say 2 liters or 5 liters, whatever the size. You add iron, you see the growth. And then he did it so many times, but still he couldn't convince the majority of the oceanographers. So 90% of the scientists, the oceanographers, didn't believe that iron hypothesis because his methods had some serious flaws because that bottle doesn't represent the real ocean ecosystem. So John Martin said, if you don't believe me, give me some iron, I will conduct an open ocean experiment. So he conducted and led and then others and conducted a 13 open ocean iron fertilization experiments for the past 18 years. And then you can see those, the sites and etc. And then just to give you couple examples, this is one Canadian scientist conduct, and they add iron, roughly about a ton of iron, and you can see this iron-stimulated phytoplankton is visible from space. This is a remote sensing detection, and this is after 3 weeks. You can see it, but you can see in the middle is a artificial induced iron bloom, the phytoplankton bloom, compared to the surrounding, the natural bloom. So they give you the spatial perspective. All right. So, and then after a week, this man-made bloom disappeared. And there's another example. The Japanese conducted the experiment, and in the northwest Pacific, you can see in the middle of this iron patch where they added, the phytoplankton increased by about a factor of 10. And then, therefore, they lowered a PCO2 at the surface by about 100 ppm. So imagine in the middle of that patch, there's a lot of CO2 transported from the atmosphere into the surface of the ocean. And then, so this is the summary slides of this, what we have learned. What we have learned is that science is certain that you add a small amount of iron, it will stimulate a phytoplankton bloom. It will take a carbon from the atmosphere. But what is not so sure, how much this carbon dioxide can be able to sequestrate through this method, how long they can stay in the deep part of the ocean. What is the unintended consequences of this iron? Some studies show that there's type of phytoplankton, the diatoms, stimulated because of iron, they can produce toxins, which will harm the marine ecosystems. And then, so those the previous set of experiments cannot answer those questions because they were not designed to answer those questions. So therefore, and a group of us, I participated, this is 3 years ago at Woods Hole, we felt that it's premature to use the iron fertilization to sell for carbon credit, like some of the private companies want to do. We, the scientists, think we are not ready. We don't understand a lot of the issues. Therefore, we need to conduct the larger, the longer scientific experiments to address those issues. We need to follow that carbon to see where they go and how long it will stay there. What is the ecological consequences, the intended and unintended? And for me, personally, I like to see those observations, the data, to improve the model, and therefore we can make long-term predictions. So those part we publish in Science, and then, but still, we have to face a lot of environmental regulations. That is because there are a lot of environmental groups against even the scientific experiments. And so they say you will harm the environment, etc. So that's where the London Conventions, London Protocols will come. It's a legal binding organization. So there's a signing countries, and then they say that for the commercial use of this type of experiment should not be allowed. But for the scientific, legitimate scientific experiments, and we should come up a set of regulations, guidelines, and how to conduct the experiment. So I have been involved in working with the London Convention to come up this assessment framework, we call it. So basically a set of guidelines that all the scientists should follow, and how you conduct your experiments, how you report your results, and then who should be responsible to do the independent assessment. This assessment framework has been adopted by London Convention just about a month ago. And then so from this point on, we, the scientists, have some hope if we want to conduct the next generation of the experiment. And then so we have some guidelines to follow. So let me summarize what I have talked to you through. I think that my 20 minutes is up. And again, I talked to you on 3 topics. The global carbon emission and the warming trend will continue, and it will have a negative impact on the environment and the society, and with the increase in population and concentrated in those coastal areas especially. And then apparently mitigation, adaptation are not adequate, not enough, because we do not see those good policies and concrete implementation plans in place in the near future. And therefore, the group of scientists and then as well as the public should consider other options to counteract a global warming. And when the disasters hit us, do we have the options? Do we have the knowledge? Do we have the tools to do something to reduce this effect of warming? This is not a science fiction. So this is a real situation. And therefore, this climate intervention and technology should be part of this climate change policy, along with mitigation and adaptation. All the scientists involved in this line of research agreed and strongly recommend that we should continue push for the government and then the decision makers to do the mitigation adaptation. But we also have to prepare ourselves for the worst. With that, I stop.
Okay. Does anyone have any questions they would like to ask Fei?
Yeah.
Go ahead,
I was
speak them out loud. Go ahead.
I was wondering, do we have any idea once the carbon dioxide has been taken up by the plankton, what the residence time is at the surface, what happens, and how much of it actually ends up going to the ocean bottom and staying there, and how much of it actually gets recycled, and what's the effect on ocean acidification? So 3 questions, really.
Good question. We have some evidence, and then how much this carbon absorbed or stimulated due to the iron, and then how fast they can turn over through the past certain experiments. If you have those small type of phytoplankton, they turn over very rapidly, and then the residence time of that carbon will not stay very long, will not be very long, and they respire very rapidly. They can emit it back to the atmosphere, so that it is not very effective. But if you have a large diatoms, those large centric diatoms, they form the chains. They're very heavy, and then there are not enough grazers to eat them, so they can escape the grazing, and then they can aggregate together. They can sink very rapidly to the deeper part of the ocean. Carried that with it is the carbon. So we have so many evidence through the sedimentary cores that happened. So there's a few experiments showed that large phytoplankton, the diatoms, carry the carbon to the deep sea. All right. After they sink out of the euphotic zone 200 meters, we never followed that bloom very closely because all the experiments only last for about a month at a time. So therefore, we cannot answer the question how long the carbon will stay at the depth. We need to address that with the new set of the implementations and instruments and stay the longer experiment, etc., and through the modeling. The last one, the ocean acidification. It certainly will have some impact, but again, this is going to be localized. What the bloom will be localized, and how that accumulated carbon at the depths and will have the impact on the surrounding areas or the downstream of the ocean, we do not know because nobody followed that part of the carbon that closely. So therefore, we need to have new set of experiments signed with the latest years and to address those three questions.
Thank you.
I've got one for you from the chat box. The question is that in the last 15 years, have you seen the fears over the danger of intervention technologies increase, decrease, or remain the same among scientists, and the same and the same question among policy leaders? So, how are the attitudes out there, I guess?
Among the scientists, I can tell you 5 years ago, and then this is the idea sounds like a science fiction, and the people certainly want to go to any conference. The label on geoengineering, they think it's a joke, right? So a lot of reputable scientists think this is, some crazy ideas out there, and etc. But the paper published in 2006, and Paul Cruzen, and then called this a research into this, and he's a Nobel Prize winner, and he had a tough time to publish that paper because the scientists some reviewers did not want him to publish it because that will cause some concerns and panic in the public, and then some scientists. But he published it anyway. The editor wrote a letter why he decided to publish it, and etc. But after a series of small workshops, including the National Academy of Sciences, and then people come to the conclusion about this ideas. We need to think about this research. Is this really effective, or is this still a science fiction? So I think a lot of the scientists in the climate change communities have some serious considerations about this climate intervention technology. At least it's worth considering through the research. We're not talking about a deployment in any way. It's the research. And then say, we understand the system well enough that what is the consequences. So, etc. That's where we stand.